I started with okay, no. Okay, I am on page 65 in my pink math journal. We're talking about the word numerator. The numerator is the top number in a fraction. Okay? We are modeling that with the fraction 5/8. So our numerator is 5. It says in a fraction the number above the fraction bar that represents the part of the whole, and the 5 is 5 shaded parts. That is what the 5 stands for. That is what the numerator stands for. Okay, then we have our denominator. It is a number that is below the fraction bar, and it represents the total number of parts. So we'll draw the same circle, okay, divide it into 8 by drawing a plus then an X. Shade your 5, okay, we don't have to have perfect artwork here. And the 8 is our denominator, representing 8 total parts. Okay, I like to think of numerator and denominator. I think we've done this before, but if this is my fraction bar, my numerator, everybody show me with your hands, numerator, denominator. And I know we have some different ways to think of that. I personally like no duh. Some people like Notre Dame. Some people just like to think denominator down. They both start with D, okay? But the numerator is the top number and the denominator is the bottom number. The numerator tells us how many designated parts and the denominator tells us how many total equal parts there are. Okay? Now, the next line down of vocabulary, the word fraction, is a symbol used to name part of a whole, part of a set, or a location on a number line. Okay? So the part of the whole looks like this. This is a whole bar divided into 4 equal parts. And if I wanted to show the fraction 1/4, okay, 1/4 of that whole shape is shaded in. If I have a set of 4, then 1/4 means 1 out of the 4 are shaded in. And then on a number line, okay, it's important to be able to visualize fractions. Please turn around, pick up your pencil, and do what I'm doing. Okay, over here on the left, we would represent 0. And over here on the right, we're representing the whole number 1. Halfway between there, we have 1/2. And then what is halfway between 0 and 1/2? Landon? 1/4. So go halfway between there for 1/4. Okay, we're going to show 1/4 because that's a fourth and that's a fourth. Okay, what's halfway between 1/2 and 1? 3/4. Okay, so a fraction can be used to show part of a whole, part of a set, or a location on a number line. Okay, we can show all of those things with a fraction. A fraction is a number that is less than 1 whole. Okay, as long as it's a proper fraction. We'll get into improper fractions later. Okay. Looking here, we have something called a benchmark fraction. A benchmark fraction is a known fraction that is commonly used for estimating. What is going to be our most common or popular fraction? What's our most well-known fraction? 1/2. So we would call that a benchmark fraction. And the reason we use it as a benchmark is we should be able to visualize 1/2, and then that should help us to know if fractions are greater than half or less than half. Okay. Now we have this term equivalent fraction. Okay. Equivalent means equal. Okay, so we're looking for fractions that are equal in value. They name the same region, part of a set, or part of a segment. So they're equivalent in value. They're measuring the same amount of a set or part. Okay, so if I started over here and I just shaded in one of these, what fraction is that representing? 1/2. How many of the parts should I shade in here to equal 1/2? Cordelia? 2. So 2/4 is equal to 1/2. Okay, and then over here on this side, how many should I shade in to be equivalent? Rowan? 4. So we would say that 4/8 is equivalent to 2/4, which is equivalent to 1/4. That also makes 2/4, which is equal to 1/2. That also makes 4/8 equal to 1/2. Okay? And then a term that we need to know for reducing fractions, which means putting them in simplest form, which means dividing the numerator and denominator by the same number until we can't divide them anymore. Okay, is finding a common factor, and specifically the greatest common factor. So we know what factors of a number are. What are factors of 6? What are the factors of 6, Eloise?
2, 3, 6.
Yep, those are them. 1, 2, 3, and 6. What are the factors of 9, Henry? 1, 3, and 9. So when we want to reduce fractions or put them in lowest terms, we want to find the greatest common factor. That means greatest means biggest, common means the same. So which one of these factors do they have, the biggest factor that they have in common? Which one is it? The biggest factor that they have in common, Carter? 3. That means I can divide my numerator and denominator by the same number. We know that to find an equivalent fraction, you either have to multiply or divide the numerator and denominator by the same number. So if I do 6 divided by 3, then I need to do 9 divided by 3. What is 6 divided by 3? 2. What is 9 divided by 3? 3. So 6/9 is equal to 2/3. That's called reducing the fraction. Other words for reducing fractions are simplest form, lowest terms, simplifying. Okay, all of that means to divide the numerator and denominator until you cannot divide them anymore because they have to be divided by the same number. Okay? Okay, there will be no laughing in math class. I'm on page 66. Okay, I told you a mean teacher was on here. Okay, so we're going to just practice reducing. And look, it's putting lowest terms or simplest forms. You have your greatest common factor that you can divide the numerator and the denominator by. So 12 and 15. What are my factors for 12? What are my factors for 12? AJ. There's one more set. You forgot.
3.
3 times what is 12?
4.
1, 2, 3, 4, 6, and 12. What are my factors for 15? Avi?
1, 3, 5, 15.
Okay, what's the greatest common factor? 3. Okay, so now you're going to divide your numerator by 3 and your denominator by 3, and that's going to give you the lowest terms or the simplest form. So 12 divided by 3 is? 15 divided by 3 is? So it's 4/5. Okay? Now, 24 over 36. What are my factors for 24? Give me some factors for 24. Stella?
1, 2, 4,
Yep, you skipped one though.
3.
Yep.
Why is it?
Now you're ready. 4 times. Yep. 3 times. 1 times 24. 2 times 12. 3 times 8. 4 times 6. Okay. What are my factors for 36? What are my factors for 36, McKenna?
1, 2, 3, 6,
You skipped one. 4 times 9. So you have 4, then 6, then you have 9. Then 3 times what for 36? 12. Then 2 times
18.
18. 1 times 36. Okay? Now, what is my greatest common factor here? The greatest common factor. Riley? No, there's a bigger one. Well, there's no 8 over here for 36. Riley? 12. Okay? So now you can divide the numerator by 12 and the denominator by 12. So what's 24 divided by 12?
2.
What is 36 divided by 12? 3. Now, I just want to say this. I'm going to come over here. If I had the fraction 24 over 36, and maybe I didn't list all the factors, and I thought, oh, they can both be divided by 6. So I divide the top by 6 and the bottom by 6. 24 divided by 6 is 4. 6 divided by 6 is 6. It's important to look. Can I divide them both again? Yes.
Yeah.
That means you didn't go big enough, and it's fine. You just, if you go big enough, if you get the greatest common factor, you only have to divide 1 time. But if you don't get the greatest common factor, you need to look. I can divide both of these now by 2, and then I will still end up with 2/3. So it's important every time to look. Can I divide those again by the same number? Please turn around. This is the second time I've asked you. And you are not following along with what I'm doing. So you can put this away and you can do it later at recess. Okay, so that is 2/3. Okay, now I'm going to give you a second here in a minute to go through this one, but let's talk about equivalent fractions. Okay, so we have to multiply or divide the numerator and denominator by the same number. How many equivalent fractions are there for 9/10? Does anyone know? How many equivalent fractions are there for 9/10? Jameson?
1, 3, 3/4.
Will?
18/20.
Well, that's 1. How many are there?
Doesn't it just keep going?
Infinite.
I know.
It's endless. You could be 9,000 over 10,000, 9 million over 10 million. It's infinite. There are no limit on the number of equivalent fractions. And some of you are trying to divide this, but 9 and 10 do not have any common factors. If you look at a fraction and the numerator and denominator are only 1 apart, there's no common factors. There's nothing that you can divide that by. So you have to multiply. So Will said 18/20. That's 1. What's another one? What else is an equivalent fraction? Gemma?
180 over 200.
Okay, I could multiply each of these by 20. 9 times 20 and 10 times 20. 9 times 20 is 180. 10 times 20 is 200. Give me another equivalent fraction. Riley.
1,800.
Yeah, we could do that by 10 again. But we could also just go times 3. 9 times 3 is 27. 10 times 3 is 30. I could go times 4. 9 times 4 is 36. 10 times 4 is 40. Okay? There's an infinite number of equivalent fractions. Okay, give me an equivalent fraction for 7/12. Give me an equivalent fraction for 7/12. Every hand should be up. Everyone should be willing to try. Dane. Okay, what did you multiply by? 12? 7 times 12 is 84. 12 times 12 is 144. Give me another one, Avi. Okay, 7 times 3 is 21. 12 times 3 is 36. Henry, give me another one. Good. 7 times 2 is 14. 12 times 2 is 24. Okay? I would pick things that are easy to multiply so you don't make a silly error. There's no reason to multiply the top and bottom by 8,763. I mean, it would be an equivalent fraction, but if you make an error, then you get it wrong. So I would keep it simple. 2, 3, 4, 5, 10, 100. Make it simple for yourself. Cordelia? 28 over 36. 7 times 4 is 28. 12 times 4 is 48. So 28 over 48. Okay, we have about 8 minutes. Why don't you work with someone sitting near you? On number 3, you have to put it in lowest terms. You have to divide. On number 6, you're coming up with equivalent fractions.